American Idol star, so sorry about that.
Say it louder. Test your mic.
Can you hear okay, great. Okay.
No,
well, so we're going to start. Thanks, everybody, for coming. Another great turnout for a career chat. My role in this won't be that much because I know you guys want to hear from these awesome folks. So today's topic is called Tackling the Technical Interview. We're pleased to have two of our most recent alums from the class of 2015, Johanna Ye and Brian Mick. So let's welcome them here. Great. So for Brian and Johanna, whoever wants to go first, before we go into the technical interviews and how to go about best doing that, if you guys could tell us just a little bit about yourselves, kind of your background before coming into the M.Eng program, and what you guys currently do in your current positions and roles.
All right, so my name is Joanna, and I was M.Eng 2015. So before, I was in the Master of Engineering program. Can you hear me okay?
Yeah.
Okay. I was a Cal undergrad also. So I stayed in this campus for a long time. So I graduated with my bachelor's in Letters and Science. Is there any Cal undergrad here? Nice. Oh, only one. Last year had a lot. This year, the audience is very diverse, as you're saying, for the Cal. So after I graduated, I thought, oh, what should I do for a career? Should I do like a job or job search, or should I do grad school? So I wasn't really sure. And I applied anyways. I have an internship on LinkedIn, and I also got an offer from Master of Engineering. So I was looking at the options. Oh, should I grad school is a good option for me, right? And then I think Master of Engineering, they have a really good professional engineering focus. So in the very beginning, we have all those engineering leadership classes, including like accounting, marketing, and just like entrepreneurial finance. I think those aspects wouldn't be directly like related to our engineering expertise, but those thinking process and the vocabulary is actually very useful in the work experience. So that's why I had got into M.Eng, and I didn't regret it at all. And after that, I applied to my job during my fall semester, and here I am. Yeah, that's me.
So I come from the other side of the country, from the East Coast. I went to Cornell University for undergrad, where there was lots of snow and ice year-round. Graduated in 2010, spent 4 years working for a restaurant oven company in Vermont, and decided that I wanted to do something other than make ovens. It was a good time, but I wanted to do something bigger, and looked at grad schools and applied to Cal and Cornell, and Cornell was just too cold to go back to, and the weather's so nice out here that I came out to Cal. So that was 2014, came out to Cal and graduated in 15 with the M.Eng at Cal, and then during fall semester, I also did my job search and ended up getting a position at Tesla. So that's where I am today.
And then could you talk a little bit about your career search while you were at Cal?
You want me to start?
Yeah.
Sure. So for my, hang on a sec. So at Cal, I used, yeah, but they're not the same. I used a lot of the Cal career services. They've got a lot of neat stuff going on. At the employer breakfast, I met with a bunch of employers, and some of them were less interesting than others. There were some that was like, okay, like, here you go, you can apply online. And that was less interesting. And there was some, GM notably, was taking interviews and scheduling them for the next day. So that's the sort of thing that's like interesting, is when you see a company that's interested in recruiting students and recruiting them soon and getting into the interview process. So things like the employer breakfasts were good. There was on-campus recruiting at the career fairs, and just wandering through those aisles and trying to pick out the companies that really seemed excited in pulling in new students. And then another thing that helped me a lot is there was, for my capstone, was American Jobs Project. Are there any AJP this year here? Woo, nice. So for American Jobs Project, I studied energy storage, and in San Jose, there was an energy storage expo for the industry. And so I went down on that and signed in as a volunteer and was able to go for free. It's normally like $300 to be an attendant. And I was able to go and take notes for the trade show and then visit all of the exhibits and go to the talks as a note taker. And I was able to meet with a lot of companies that were there in the energy storage business and talk to them about what they were doing. And just being at the trade show and meeting the companies and having the business cards is another really good way to find connections with potential employers. And it's something that's not through Cal, so it's something you have to go sort of outside and look for. But the Bay Area is pretty busy. It's a popular place for trade shows. And so I recommend at least doing a Google search and seeing if there's something in the area, because that can be a really powerful way to find potential jobs as well.
Yeah, for me, I took a lot of I went to a lot of SIM events. So on campus recruiting, there's Carissa, and you can browse a lot of job opportunities there, and send out your resumes early. So that's what I did. I applied to a bunch of, I did like filtering and then took the top results, and I applied to like every single jobs that allowed me to submit resume and met the qualifications. And I heard quite a few back. And also, the career fair is an awesome opportunity. There is, I believe, like EEC's career fairs spaced out during the fall semester. And always try, if you can, try to go early, because afterwards, recruiters sometimes they can be like a long line, and you have to wait for a long time, etc. So be proactive in career fairs, and the next step would be interviews.
And then the last call out I want to give is to the awesome folks who work in career services here at Cal. Jocelyn, Joy. Julie, I guess, is out on leave. Wait, are you not career services? Is that what that face was? Wow. Joy's awesome. Jocelyn's our hero.
Awesome.
They definitely go to them, ask for help. Yeah. They're there for you. They're great resources, and they're amazing people. So.
And I'd like to put on record that I didn't tell them to make this slide, so video recording. And then last, just general pieces of advice, because right now students are just beginning their job search. Just pieces of advice either about your career search or just about their capstone, about the M.Eng experience in general. Just words of wisdom that you can give to them.
Find things that tie in with your capstone to what you want to do in real life. And focus on those, and really take that to your employer and show them, like, hey, I'm doing something cool here at Cal, and this is how it relates to what I want to do that's cool for you.
Yeah, and I would think try to just practice the things you learn in engineering leadership classes into your capstone project, like how to collaborate with teams, and how do you guys communicate all the responsibilities so no one is taking the same job, etc. And in job interviews, sometimes they will ask you, what's the most challenging project, or what's the difficult time in your project, etc. And you can start practicing as you begin to interview, or even before you start. It's always what's your time, and try to articulate what you're working on during your master's, and try to practice like just talking about your project.
Great. Thanks, guys. So we're going to transition into their part of the presentation. We're going to how to best prepare you guys for your technical interviews.
Thanks, Jocelyn.
Thanks.
All right, so we're going to give an overview of technical interview. Unfortunately, I'm a mechanical engineer, so that's my perspective. And
computer science. So can we do like a survey of the audience to see what majors that audience is composed of?
So how many of you are mechanical engineers? And then how many CS or EECs? And then how many are not either of those two? Gotcha. So we apologize that our expertise isn't going to line up exactly with people from other majors. We hope Jocelyn can put together other things for you guys. I think between mechanical and EECs, it looked like more mechanical.
Yeah.
So we'll lead with that for our sample. But we can certainly talk about that. So that there's the sample is kind of specific to one field, but everything else we'll talk about applies across the board for technical interviews. We've got some potential topics that we can share with you. I've got a sample to show you guys. And then the biggest thing, which we'll talk more about at the end, is how to play to your strengths.
Right, and I just want to point out, no matter what major you are, some articulations is applicable to all the interviews. So, for example, how do you present yourself? And when you look at an open problem, like how would you articulate your thought? And what does the interviewer focus on? How do you communicate? And those are like across all the interviews. Yeah. Exactly. So focus on those upon the sample, because you guys are all different majors, but all the others apply.
You want to lead with computer science?
The topics?
Yeah, just what you guys did for your interview.
Right. So I'm going to talk a little about the computer science interviews. It varies a lot depending on the company. So smaller companies, generally, they might want you to start with like a person who can just jump in and do the work. So they will ask very specific questions according to what they are working on. So my personal experience is that my very first interviews with a small cloud business startup, and they asked me very specific programming techniques in C++. But that's not very general. But general interviews, like large companies specifically, they would like to ask algorithm questions just to test like how solid is your like data structure knowledge at school. And in general, operating system knowledge is like how, for example, like cache, thread, process, and those are like computer architecture terms, but like general computer science knowledge. And just ability to code and to think fast and not to get stressed out during like a short interview, I think. Yeah.
Cool. Thanks, Johanna.
So what, an example, like if you're going, and this is, will probably pertain to both of you, if you are approached with a technical question and you have no idea what the answer is, what would be the course of action that a student would go through in that situation?
That's a very good question.
So the first thing I would say there is tell the interviewer, like, I don't know exactly what the final answer is. I'm not familiar with this material, and then step through your thought process. So say what you think about, say what you do know and how it relates to the question, and sort of explain your knowledge, and don't try to cover up your shortcomings, because the interviewer is someone who's worked at the company for a long time. They know the answer, and it's easy to see through an answer that's not correct, and that will look bad on you. But it's better to say, like, I don't know, but this is what I do know, and here's how I would find the answer in the field.
Yeah, exactly. So I second Brian's opinion. Just first and foremost, try to be honest, because they match you with people with expertise that you claim you have on the resume, so they will know what you're talking about. So don't try to cover up what you do not know. And secondly, don't be afraid that you might not know, because sometimes it's very expected. They want to see how you react under pressure, and how would you solve a problem without knowing the necessary knowledge. But you can tell them, oh, I'm thinking of this way, or clarify the question furthermore. Maybe it's not what you intend to ask, etc. So clarify the question and articulate your thought process. Like, how are you beginning to approach a problem that you don't know, and how do you relate to the knowledge that you actually have? Can go on.
Sure, I'll talk. So for a mechanical interview, there's typically a couple of steps. You'll have a couple of phone interviews, and those are mostly screenings to make sure there's nothing immediate that stands out as something that would prevent you from being hired. And then you'll be either brought on campus, or you'll have a telephone technical interview, and that's typically with an engineer instead of with a recruiter. If it's on campus, it can be very in-depth. If it's on the phone, there will probably be at some point, you'll probably get invited on campus for your final interview, because they want to meet you and make sure you're not crazy. It's important. And so the types of questions you'll be asked are things like, there's technical questions related to your experience in school and stuff, like beam bending and stresses and computations for thermal expansion, any of a variety of things you've done in grad and your undergrad work. And then there's also like a second group of questions that are more creativity questions. And those are the kind of things that can catch students a lot of times off guard if you're not ready for them. And it's a question that seems like totally out there, and you're like, what does this have anything to do with work? So one of my favorites that my friend got asked while he was interviewing for a job was, name the different kinds of lamps. So open to the audience. Get my marker going. Different kinds of lamps, please. More? I've got 3. Desk. Floor. I heard touch. LED. Good, keep going. Wait. Magic. Here we go. What's in a magic lamp? A genie. I heard clap on somewhere. Yeah. More? Heat. Mosquito. I can't spell that. Citronella. Yeah, like I can spell that either. Bug. So this is the kind of question that at first you can be like, lamps? Like I'm applying for a job for a company that makes inverters, for home electric energy installations. Like, what does lamp have anything to do with it? And what we're interested in seeing with a question like this is, how creative are you? How much are you bound by traditional thought, and how far can you go outside the box and come up with answers that, sure, it's a lamp. It's not what you think of at first when you think of a lamp, but it's something out there, and it shows the ability to like expand your mind and think beyond the classic like oil, LED. LED's pretty good. Oil and gas are like the first things you think of as like it's an oil lamp, it's a light. And then going to things like a magic lamp or a heat lamp or things like that, where it's really it's stretching the definition of lamp, but it shows that you can stretch your mind and you can go beyond what's on the surface, and that's something that we're really interested in seeing. Anything you want to add?
So also, as interview questions, they have like algorithm and coding questions for CS, and they also have system designs. For algorithm and interview questions, make sure you might be able to like see the books on websites a lot of times, but not enough people do it. Is one, clarify the questions. Is it actually the question you are answering? A lot of times, when you think you're answering the question, but at the end you're totally not answering the same question that the interviewer is thinking you're answering. So that's very important. And then also, when you code, go line by line through your thought process about even when you are finding the bug, you need to articulate about, okay, why do I think some logic is wrong up there, and etc. And also, there's system design questions, open-ended questions. And during the process, like sometimes there's not really a real answer or like right answer. It just the interviewer would discuss the interviewee with like what the interviewee is articulating and how and the topics it's covering, and drill you down to see if you really know what you're talking about. So yeah, and there's not that much creativity, I say, in the computer science interview. So this is not like that typical of a computer science question. But I say, and just be open-minded to possibilities, and always be prepared to back up your thoughts.
So Johanna, so what would be a sample question? You don't have to go through it. But.
I think it would be like take like an example answer from the audience. Okay. Let me think of a design question. Okay, so for example, I give you a string. This is a very, I think it's broad question. So give you a string, and it determine if it is a number. So, like, what would be the first step? Give you a string. Sorry.
You can ask the audience.
Yeah.
I'll just write.
What would be? Would you start writing? Yeah. So we will take one answer first. Yeah, go ahead. Convert to integer type and print out.
So what if the string is this? Where if you convert that straight to an integer, because it has an E in it, E gets converted by ASCII, and you end up with like 70, I think, lowercase e.
Right. Okay. So the first step I would do first. I'm not okay. So first step I would do is to clarify what is an integer, right? So for example, if okay. For example, we do 140.0, and then in a lot of languages, it's characterized as float. So it's not actually integer. but you can see it as an integer. So if I were the interviewee, I will first clarify what's the definition of integer. And for example, for this number, for 8 to 10 to the fourth, it's actually an integer, but it's not like really format of integer. So I'm not exactly sure what the interviewer wants. So first of all, I would clarify the question as example. Then what would be like the traps you think might go through the interview? So if you say, for example, if you clarify the criteria and then write it with a program, right? And what might be like the trip-ups, the pitfalls that you might do? Okay, so for example, is it out of the range of the program, right? And et cetera. And then you have to deal with it differently. And a lot of things that, so it looks like a simple question, but sometimes people might not be able to solve it in a 45 minutes interview. So you might be like careful, you might be creative. For example, you would clarify like, oh, there can be formulated in a lot of ways, but in the end, interviewer might want to deal with like a certain subset of the ways that you might think of, and then you deal with it, and then you articulate your thought, and that's fine. Because in the real software development environment, the developments are done by like iteration of process, and that's how we should approach interviews, questions like iterations of process. Yeah.
Going back to mechanical, there's another group of questions that as a student here I found particularly difficult, and that's the manufacturing questions. So you'll get questions like, how is something made, or how would you make something? My interviewer, when I was there at Tesla, drew something like this. Hang on, I've botched my bottom edge. And he said, if you were going to make this out of plastic and you wanted to injection mold it, how would you do it? And for someone who worked in ovens for a while working on metal, it was a difficult question for me because I'm not familiar with plastics. And so I just told him that. I was like, I don't work with plastics very often. I don't know very much about injection molding in that process. And so then he opened it up. He was like, okay, for injection molding, you can't do vertical edges because it won't come out of the mold. So you have to have draft on all of your vertical edges. You have to slope them in a little bit so it comes out of the mold. You have to designate some line of the part to be the split where the two halves of the mold will come together. And he told me that, and then he said, given that information, now how would you do this part? And then I was able to say, okay, if you put your split line here on this line, and then you draft this edge and draft this edge, draft it the other way, up to the split line, then and draft this edge. Then you have a plastic part that now can come out of the mold, and you can create it. And then he took it a step further, and he said, what if you wanted to do this without any draft at all? And again, this is difficult for me because I've never done plastics before. So it's like an unknown question, and he's checking how quickly you can learn and how you can take the information you've been given and adjust your thought process and your engineering process to solve the problem. And I said, well, if you take this part knowing you can't have vertical edges, you can change the angle of your split line, and you can change it to be perhaps your mold splits here across the part that way, and then all of your edges are 45 degrees, so you have no problems opening the mold and getting the part out. And then you can create a part with 90-degree edges and have it be injection molded. And that's something that I didn't know. I didn't know going into the interview, and I was able to talk to him and sort of explain my shortcomings and what I didn't know, and he gave me the information I needed to put together a solution and solve the problem. And so that sort of thing is powerful when you're doing an interview and you don't know. You can, to Johanna's point, you can clarify the question and ask for help, and they'll often give it to you because they want to see your thought process more than they want to see you stumble on something you don't know.
Yeah, that is true for computer science interview as well, especially.
We have time. So I have another fun sample. I've got some bolts, and these come from one of our cars. Pass this one around the back. I need these back, by the way. Don't take these. Pass them around. Take a look at them. So one of my buddies does an interview question where he hands out this bolt, and he asks you to tell him about the bolt. And that's all he says. He says, "Tell me about this bolt." And it's another one of those like lamp questions where it's kind of open, and you don't know what the interviewer is looking for at first, and you can get kind of tripped up and be like, "Well, you know, I don't know anything about this bolt. Like, you just give me a bolt. Like, help." But just looking at the bolt, you can start saying things about it. So those of you who have had a chance to touch it, tell me something about it. Good. Half threaded. Anodized. What was that? A blue point. It's a patch. It's not on the end. I can't spell unusual. I'm an engineer. It's close enough. Yeah, so there's a lot going on this screw. You can tell, another thing is the threads don't go all the way to the tip either. There's an unthreaded tip. The bolt head has a built-in washer. Pardon my handwriting. What's that? It's about 3 inches long. And then the interviewer might ask you, why might you want some of these features? And so, yeah?
I wanted half threaded because you need to go like pretty far in before it screws them apart. Might be something in between the washer and the threading.
There's parts in between. It passes through something to bolt to something else. That's exactly right. The fact that it's made of metal means it needs a certain strength. You can get fasteners made out of plastic, and those can be lighter. The fact that it's anodized means it comes in contact with something that might be corrosive to the original bolt. The fact that that blue patch is a nylon thread locker, so it helps the bolt resist vibration. It helps it prevent from backing out. The unusual drive means you don't want somebody else taking it apart. It's not just a Phillips or a standard hex head. The unthreaded lead-in helps the bolt line itself up with the threads it's going into, which ties into the fact that it's half-threaded, it goes through something else, and it's 3 inches long. So from your position where you're driving the bolt, it's a long ways in bolt world up to the threads you're trying to engage. So having that smaller tip that helps center the screw and finds the threads that it's going into. And so there's all this sort of thing, and what the interviewer is looking for is that when presented with something new, you don't stumble and get tripped up and get stuck in this oh my gosh, I've never seen this part before, I have no idea what it is. Like, I don't know. That's the sort of thing that the interviewer sees and is like, okay, this person has a hard time adapting to new designs, adapting to new concepts. That's something that we're disinterested in, and something that we're interested in is when you just start, even with something simple. Well, it's made of metal. It has a certain minimum strength. I think the head of it might say something about, can you read the head of the bolt? Whoever has it. Does it say anything on the head? I don't know if this one has any markings or not. No? Oh, yeah. What's it say? It's probably 10.9. 10.0, I don't think is a bolt we use. I can't read it, though. 10 point something. I certainly understand after it gets formed, it can be hard to read. This lists the strength of the bolt. There's different grades of bolts, and so this is about halfway in between. They start at 8 and they go up to 12 for bolt strength. So that tells you something about it. It could be stronger, but it could be weaker. It's kind of right in the middle. There's just a lot going on with a part that's really so. It looks at first like, oh, it's just a bolt. You can use any bolt, but there's been a lot of design engineering that goes into making the bolt the way it is, and each one of these features adds money to the part, and they're not there just because we felt like throwing it on. Like it'd be so much simpler to go to Home Depot and buy a standard hex bolt, 3 inches long, fully threaded. Like that'd be easy. But we've chosen to use something else, And every single one of the features that's not like a classic off-the-shelf bolt is there for a reason, and we want to see if you can A, pick those out and say like, hey, this is different, this is different, this is different, and then B, you sort of can think through like why might you want it to be anodized, right? Why might you want it to only be half-threaded? Those sorts of things, and being able to pick those out and explain them to your employer can help make you look like a more attractive candidate.
Right. So some of the points that Brian made is also applicable to computer science interviews. We have a type of question called like system design questions. For new grads, they might not necessarily ask that question, but just as we need to have the articulation in the code problem in the coding practices, that we need to be very precise with edge cases. We need to make certain assumptions when we do system design interviews as well. So for example, a very famous question is, oh, how would you design, like, for example, Instagram? And you might think, oh, there's a lot of pieces to Instagram, where do you start with? But you can first think about, like, what does the client side look like? What's the server side look like? And then what are the pieces we need to put in the client side and the server side? And then to show the interviewer that you have a big picture and you know how to do things from end to end, versus speaking about what kind of versus like going into what kind of database should we use first, and what's the programming language we're going to write, and etc. So yeah, that's very helpful.
Another piece of a technical interview may be a written test that you have to take. Some companies in the area are having tests for interviewees, and those sorts of tests can cover sort of a wide range of topics. Some of them are questions like mechanical design, so they'll give you a picture of a wrench and they'll specify some force on the handle and ask you what the maximum torque on the head might be, and given the size and specifications, you have to do an analysis and come up with what the torque the wrench can apply is before the wrench breaks. Some of the questions are more abstract, like they'll show you 3 different beams, shapes, cross-section shapes, like an I, maybe an L, and maybe an H, and they'll say that there's no dimensions. It just says, assume they all have the same cross-sectional area, which one is the strongest in bending? And so that's more of a conceptual, how well you know your beam shape type questions. Some of them are questions on buckling, questions on stress, questions on loading. It's like free body diagram type thing. Make sure you know all of those base engineering questions, and what we're looking for on those basic questions of the test is that you haven't forgotten any of your undergrad engineering classes. That you can do the math and you can do the physics, and you sort of understand on some level what the engineering principles are behind the design. And then there'll be questions focused more open-ended questions, and they start to get more technical, like you have a plate and it's heated to a certain temperature and it's made of certain material. How much does a plate expand by? And that's the sort of thing where they don't give you the coefficient of thermal expansion, and they expect you to look it up, to have a book or have to be able to go online, if they let you use a computer, to have some means of looking up what that coefficient is, knowing what a property of the material that you're looking for, and then applying it to the problem at hand. Most of these tests are open book. They'll give it to you on paper and ask it back by a certain day, and it's totally open. You can use any materials you have, just not other people. Someone else can't take your test for you. So you have the ability to look things up online and be like, okay, like I need the properties of this material. Let's go find it. And knowing how to do that is important for a job, because you won't have textbook examples where here's all the materials, properties that you need to solve the problem. It's more open. And then there were some questions sometimes about parts and about manufacturing. So questions like, how would you make this? Or questions like, how is this made? And you can sort of tell by looking at the material and looking at the marks on it. If it has cut marks from machining, you can tell it was machined. You can tell if it has a smooth sort of modeled surface, you can tell it was cast. And then there was a couple of questions on engineering drawings. So you look at an engineering drawing and you're asked to point out errors, or how would you improve the drawing. And so that's a matter of being able to look at something and it shows the 3 2D views of the part, and being able to visualize it in 3D and say, oh, that there should be a hidden line on this view for this feature somewhere else. that's sort of going away as CAD does it all for you. Being able to actually do drawings by hand is kind of gone, but you'll still see them on tests, and more than some of the tests are designed. Some of the tests will be timed, and they'll email it to you at a certain time and ask for it back, and some are just open. You have a day, you have a week to get it back, and what they're looking for, especially if there are problems that you can't solve, looking for how you set it up and how you might go about solving it, or what you need to learn to solve it, and even more than that, more than not having a solution, solutions that are obviously wrong are red flags. So if you do some math on some component and you come up with like a negative kinetic energy, it should immediately raise a flag, and you're like, well, this is the answer I got, and I'm out of time, so I can't fix it. But I know it's wrong, right? That this number shouldn't be negative. This one shouldn't be so big. This one shouldn't be so small. Being able to have some engineering judgment when you go in and take this test and highlight things where you're like, okay, I've run this through the equation, but my gut says it's wrong, and that's a very powerful thing to say, especially if it's a time test and you can't actually go back and find the real correct answer. Is we're looking for sound judgment in your engineering analysis.
Yeah. So for computer science interviews, some companies do like a small online coding test. And through those online coding tests, they will determine if they will give you a phone interview and next time an on-site. So for the coding test, what can remember is that there are a lot of websites and also competitions with problems out there. For example, I think it's called hackerrank.com. And also there are a lot of other websites. And just keep doing those as like a daily exercise every day. If you can, if you're not like too burnt out by schoolwork. But the point is that every free time you have, you will not regret like taking time to practice. Even for like other majors, you can practice amongst your like project groups, for example, when you're like hanging out just for free time, and practice with each other about like, I believe we did this as part of the leadership course. Just talk about who you are and what you are interested in, do a self pitch, and then talk to each other about your self pitch until you're comfortable with it. And for coding interviews and design interviews also, like you can get a lot of different perspectives and also interview experience with your peers who are also interviewing. Because every year the interview process might differ, and the feedback and suggestion from each other is very valuable within the program. Yeah.
And then but before we jump to question and answer, the other thing Johanna and I wanted to talk about was that before you go into any of your interviews, that you ask yourself, why do you want this job, and why should that job want you? And sort of prepare in your head some reasons for going after that job, because there's going to be a lot of other people applying for that job, especially if it's a company that has a lot of it's in the Bay Area, it comes to the career fair and has all these applicants, and you want yourself to stand out. And one of the best ways to stand out is why you want to be there, is having passion or having excitement or even just knowledge about the products they make. So, if you go to a company and you have no idea what they make and you're like, hey, I saw you at the career fair, you look cool. It's like, okay, like I'm glad you're interested in working here, but do you even know what you would want to do for us? And so having a knowledge of what you want to do, because if you're doing what you want to do, then you'll be happier at that company. And so prepare that ahead of time, and don't walk into a company and say, so what do you make? Because it's like, okay, I guess you're not that interested in what we do.
Yeah, and so beyond that, don't just say, oh, I have passion for this product. So my recommendation is that do some research about what the company is doing, and actually brought about some points. For example, oh, you use like Google Cloud Platform, and if that person actually like works on Google Platform or like knows that, and you know that you are already familiar and interested about that piece of technology, that matters much more than you just are passionate about saying you have passion for something. So research before talking to a company is actually important. And also, I think when we're interviewing the company as much as they're interviewing us. So just be mindful of like after school, there's like, I never thought like, it's very different from school, and you're spending like your whole day at work and with this group of people. So it will be a very long day in the end. So make sure it's something you're actually interested in doing, and you're interested in like interacting with people, and those are people like you look forward to becoming, because you will be like the people you spend time all day with. So if there's someone that you really look up to, if there are engineers in the company that you really strive to become, and then it will play much more than the compensation package. Say. Yeah.
I think that's all we have prepared. We got plenty of time for question and answer. And does somebody have those bolts? Can I get them back? Is that all three or just two? Two and one more? Yeah, if someone could pass those forwards, that'd be great.
All right, questions?
Questions? Can we pass the mic around?
The website you mentioned, daily test.
So the question was, what website did you mention,
Oh.
Johanna, about the?
Oh, I think you can like just Google for those websites. There are plenty out there, but I think what I remember. Can you see this, or should I write it bigger?
Bigger.
Right.
I'll also email it out to everybody.
Oh, word. Thanks, man.
Is there any website or material we can prepare for the mechanical interview?
Hacker rank?
Yeah, I think it's HackerRank, but just Google HackerRank and you'll find HackerRank. It's somewhere you have like online tests, and it compiles and it tells you how you do.
Can you hold the mic closer? No.
Any website for the mechanical interviews to prepare?
I don't know. I haven't looked. Sorry. Yeah?
Is it possible if someone is a mechanical engineer and say they're in controls instead of these certain product design aspects you mentioned to be generalized and actually ask those kinds of questions anyways, or would it be specified more based on your concentration and just your overarching specialty?
Depends a little bit on the job you're applying for. So if you apply for a very specialized controls type job, you maybe ask much more in-depth technical questions for that job. If you apply to a job that's broader, where you may be doing design on a bunch of different products, you'll probably get asked more of the creative design questions.
Yeah.
What's the best and worst part about working for Google and Tesla?
The best part is.
Could you repeat the question? Just
Right.
Yeah.
Yeah, no problem. So his question is for us, what's the best and worst part of working for Google and Tesla? I haven't found the worst part yet. But say the best part is definitely the people. Like everyone on my team is from a different country, with most of them have 10 years plus of industry experience, and I'm learning a lot from them every day. For their experience, and also for their like just life experience in general in different countries, and how they their perspective of the world and life, just talk about like talk to really smart people about their perspective and experience is the best. And I say the word, it's also can be a lot of like stress, because like we are entry level engineers, and we're like learning a lot from people around us. So sometimes it can be stressful, like how come we are not being as productive? But I think I'm adjusting to that by knowing that, okay, I'm so much younger than them, and it's also a good thing that I'm learning so much every day. As long as you can handle that stress, I think it's pretty good. It's pretty awesome working at Google.
The best part of working for Tesla was Wednesday night. I was test driving a P90D Ludicrous and pulled up at a red light next to a Maserati and left it in the dust. And the worst part was coming in Sunday and working 4 hours on a part, and then coming in Monday morning and being told that everything that it matched up to didn't fit anymore. And I was like, what happened between 4 p.m. Sunday and 9 a.m. Monday that made my part not fit? And it turns out everybody else was in Sunday night mucking with their parts, and then nothing fits anymore. It's just like
So don't work on weekends.
working on a weekend and having it not matter sucks.
The part you were working on that bolt of it?
No.
Other questions? All right. Well, oh, wait.
Can you briefly describe the teams that you're working on at Tesla? Yeah, and
Sure. So I'm on the battery engineering team at Tesla. I work on powertrain battery engineering on the mechanical side, so not the chemical or electrical, but all the mechanical parts that go into the battery of the car.
Great. So I work in Google Search. The specific thing, it's a full stack project. I work on like a very small part, like of a feature that hasn't been released yet. So it's just like full stack over like, I'm more on the backend side, but I also learn the front end side. Yeah.
So I have a question. I'll get to your question too.
So when the interviewer asks you, do you have any questions for us? Like what might be the good questions?
Questions to ask the employers when they ask you, do you have any questions for them?
I would definitely ask them about the culture of the workplace and the sorts of things they do. It shows that you're interested in more than just coming in and working 9 hours a day and being miserable, but being able to, if you're hanging out with these people all day long, 4, 5, 6 days a week, it's nice if you like them. And so asking about like, how's the culture, how's the food, how's the time off, what do you guys do in your free time, you know, questions that show that you're interested in doing more than just work are good to see.
Yeah, I totally agree with Brian's opinion. And so actually ask questions when they ask you, do you have any questions? And for questions, they better be very thoughtful, and better be beyond like the regular questions. So don't ask like how much vacation do I get, but ask about like, so what are like the challenges of the project, for example, that you're facing, and getting like technical insights and getting into their daily life and what your life might see when you actually join. So ask the questions that make they think you might be someone that they're interested in working with, because when you enter a job, like me, I have a lot of things I don't know, and but they welcome you ask questions, and I appreciate you striving to be like a good engineer like 5 years from now. Yeah.
All right. Well, that's all we have for today. If Brian and Johanna, if they're able to stick around after the presentation to answer some questions, are more than happy to do so. But otherwise, thanks everyone for coming.
Thank you.
Thanks.
Why don't we turn this off?
Thank you.
Thank you.
Thanks, y'all.